All right, short video here, discrete probability distributions. These distributions have a finite number of outcomes, as you can see here. Finite number of outcomes, meaning there's only so many possible outcomes to the event, to the experiment, event, probability of the event. And they're going to be numerical, right? They're going to be numbers. Right? So these are numerical outcomes. There's only a finite number of outcomes. First question you're going to be asked is it a valid probability distribution? So basically, this is the distribution of probabilities of possible outcomes of some experiment, something that's happening. In this case, I just made some numbers up. Let's call these test scores. Let's say the only possible test scores on this test, you can either get a 20, a 40, a 60, a 75, or a 95. Those are the only possibilities, just for argument's sake. All right, so if you're asked, is this a valid probability distribution? So we have the outcome and the probability of that outcome. We call this x sub 1. This is the first possible outcome. This is the probability of that first possible outcome. Second possible outcome, probability of that second. Third, probability. Fourth, probability. Fifth, probability. So two things you got to check. Are all the probabilities between 0 and 1 like we talked about when we first introduced probability? Has to be a number between 0 and 1. Could be 0, could be 1. All these numbers are, in fact, numbers between 0 and 1. So it fits that condition. And they must add up to 1 because there's only 5 possibilities. So the probability of one of these things happening has to equal 1, right? So these probabilities must equal to 1. If I ask the question, what's the probability of getting a 20 or a 40 or a 60 or a 75 or a 95? You're going to add those up because they're mutually exclusive, and you're going to get 1. It has to be one of those scores. So once you determine that it's a discrete probability distribution, we're interested in finding the mean of the distribution, of the entire distribution, and the standard deviation of the entire distribution. Now notice these are not simple formulas, right? These, if you had to do this by hand, this would be a real pain in the butt. So this is why I'm going to show you how to do it on the calculator. This is something you really need. Your calculator and your stat function is going to make this very easy to do. Otherwise, you got to do this by hand. And you got to do this by hand. That would not be fun. That would not be a fun thing to do. But I'm going to show you exactly how to get these numbers. Now, I already have the results here, but I want to show you how we get those results. So I'm going to share my screen and show you on the calculator how to input this information and get the desired results. All right, so here's my, what the hell's going on here? There we go. All right, got my calculator, my handy dandy online calculator. I am turning that baby on, clearing the screen, and now we can start. So what you're going to do is you're going to go to the stat menu and you're going to create several lists. And this is going to allow us to calculate the values that we want. So you go to edit, hit enter, and I've already input the list for time saving sake. But you can see here in list 1 are the possible outcomes. There's only 5 possible outcomes. These are the 5 possible outcomes. List 2 are the probabilities associated with those outcomes. So the probability of 20, outcome of 20, probability is 0.31. Outcome of 40, probability is 0.17, and so on. Now there's a quick check here to make sure the distribution is valid. If you take the sum of this list, it has to equal 1. You can trust me on that. This sum of this list does in fact equal 1. So the first thing we want to do is find the mean of the distribution. So you're going to create this third list. You're going to go up to the top level. And let's see, I'm going to clear it and show you exactly what to do. So this list is cleared. We'll clear this list also so I can show you what's going on. So to clear it, you go up to the top, you hit clear, you come back down, the list is cleared. So once again, outcomes, probabilities. We want list 3 to be the product of the outcome times its probability. So you go up to the top row here, and we're going to make this list. We can define this list using the other two lists. So we can say L1 down here times L2. So now when I hit enter, this list is going to populate with the product of this number times this number. It's going to be the first entry, this number times this number, second entry, and so on. So when I hit enter, it does that for me. So now all these numbers are the product of these two first lists. Now if we go back and look at our formula for the mean is the sum of what we just created. That's the list we just created. Each individual outcome times its probability. So if we take the sum of all those products, we get the mean. So back to our screen. And if we take the sum of this list, we're going to get our mean. So we go to Stat menu, we move over to Calculate. We want one variable stats, so we hit enter. We want list 3, so we're going to enter list 3. We don't care about this next input. We go down to Calculate. We hit enter. And be careful now, this is the mean, the sum of that list. Even though this says mean, this is the mean of that list. That's not what we're trying to find. We're trying to find the mean of the distribution. And the mean of the distribution is the sum of this third list. So this is the mean. This is your answer to the mean. And then, again, give it a common sense check. Look at the distribution and say, okay, 20, 40, 60, 75, 52. Yeah, it looks like the probabilities, about half of the probabilities are below that, half of the probabilities are above. So it makes sense, right? If you came up with 2, you know something was wrong. If you came up with 92, you'd know something was wrong. So give your answer a common sense check. The mean of the distribution here is, in fact, 52.15. So that's our mean. Now we need that number to come up with the standard deviation. Okay, we got to put that number here in our next list. We're going to create a fourth list that's going to be each individual observation minus that value that we just found squared times the probability. So remember, these values are going to be in L1. This value is a constant, it's 52.15. And these values are in L2. So we're going to create a fourth list now that is L1 minus 52.15 squared, that whole thing squared, times L2. And then we're going to take the sum of that list, and we're going to get the value that's underneath the square root sign here, which is going to be the variance. Okay? Now we're going to see that it comes out to be this number, and then we take the square root of that variance, right? Because we know the square root of the variance is the standard deviation. So we're going to create a fourth list using this. We're going to take the sum of that list. That's going to give us this number. And then we're going to take the square root of that variance to get the standard deviation. All right, so let's see how we do that. All right, so we go back to Stat, Edit, and we have our first 3 lists. We want a fourth list now. We're going to go up to the top and define this one. Make sure you put parentheses around the first argument here. And this is going to be the observation in L1 minus the mean that we just found, 52.15. That value squared times the probability, which are the values in L2. So this is how we want to define our fourth list. Individual value minus the mean squared times the probability. Again, when we hit enter, that's going to populate this list with those values. We see that. So we want the sum of this list. That's going to give us the variance, right? So we go to Stat, Calculate, one variable, L4 now, and we take the sum of that list, and we see it is 726.6, like we saw on our board here And if we take the square root of that number, we're going to get the standard deviation. Okay? And we did that here. 726.6 was the sum of list 4. That's this value underneath the square root sign. That's the variance. It's here. And then if we take the square root of that number, right? Take the square root of the variance, we get the standard deviation. If you square the standard deviation, you get the variance. Square root of the variance is the standard deviation. All right, so that is what you want to know about discrete probability distributions. There's a finite number of outcomes. It's a numerical measure. You have to determine if it's a valid distribution first. And once you do, and you have all the information, you form those lists to find the mean and the standard deviation and the variance. Good times.